Early August, 1941. A dirt road near Smolensk, western Russia. The German reconnaissance patrol approached the abandoned Soviet tank cautiously, weapons raised. The T-34 medium tank sat motionless beside the rutted track, its long-barreled 76mm gun angled toward empty fields. No crew remained, no demolition charges had been placed. The engine compartment showed no battle damage. German soldiers from the 7th Panzer Division circled the vehicle warily, noting details that contradicted every briefing they'd received about Soviet industrial capability. The welded hull construction looked crude, almost primitive, with visible weld beads and rough finishing that would never pass German quality inspection. The cast turret bore the distinctive rounded shape that made T-34 seconds recognizable from great distances. But what captured immediate attention was the notation chalked on the fuel tank in Cyrillic script by the Soviet crew before abandoning their vehicle. Kursk to, here, 520 kilometers, fuel remaining. A German tank officer translated the marking for his men. 520 kilometers, over 320 miles, on a single tank of fuel. The number seemed impossible. German Panzer III and Panzer IV medium tanks required refueling every 100 to 150 kilometers under ideal road conditions. Combat operations reduced that range dramatically to perhaps 80 kilometers before fuel exhaustion forced Tinger operations. This Soviet tank had apparently traveled more than 3 times that distance and still had fuel remaining when abandoned. The mathematics made no sense according to everything German doctrine assumed about Soviet technical capability. Either the marking was propaganda meant to deceive, or Soviet engineering had achieved something German designers believed impossible for a medium tank weighing over 26 tons and capable of battlefield speeds exceeding 50 kilometers per hour. The patrol commander ordered immediate recovery. This tank needed to reach German testing facilities intact. Wehrmacht intelligence had received fragmentary reports about new Soviet tanks encountered during the opening weeks of Operation Barbarossa in June 1941. The descriptions seemed exaggerated, Soviet tanks with sloped armor that deflected German anti-tank rounds, wide tracks that crossed terrain impassable to German panzers, diesel engines that somehow provided both power and exceptional fuel economy simultaneously. Many German officers dismissed these reports as confusion and battlefield stress. Soviet industry couldn't possibly produce such vehicles in quantity. The abandoned T-34 near Smolensk would prove otherwise. What German engineers would discover about this crude-looking tank would trigger fundamental reassessments of armored vehicle design that would influence German tank development for the remainder of the war, not through superior firepower or impenetrable armor, but through achieving operational ranges that German vehicles simply could not match. A T-34 that could travel 300 miles on internal fuel could operate deep behind German lines, conduct sustained operations far from supply bases, and exploit breakthroughs that German tanks lacked the range to pursue. Operational mobility derived from fuel efficiency would prove as decisive as any weapon system. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Eastern Front in summer 1941 presented German forces with their greatest military challenge since the beginning of World War II. Operation Barbarossa, launched on June 22, 1941, committed over 3 million German soldiers, 3,600 tanks, and 700,000 horses to the invasion of the Soviet Union. German planning assumed Soviet military collapse within 8 to 12 weeks based on intelligence assessments that proved catastrophically wrong. The campaign opened with spectacular German successes. Entire Soviet armies were encircled and destroyed in massive pocket battles at Minsk, Smolensk, and Kiev. Hundreds of thousands of Red Army soldiers surrendered. Thousands of Soviet tanks were destroyed or captured. German newsreels showed endless columns of prisoners and masses of destroyed equipment, creating impressions of total Soviet defeat. But disturbing reports reached German armor commanders from frontline units. New Soviet tanks had appeared that possessed characteristics no previous Soviet vehicle had demonstrated: The KV-1 heavy tank mounted thick armour that German 37mm and 50mm anti-tank guns could not penetrate from any angle. The T-34 medium tank combined mobility, firepower, and armour protection in ways that exceeded any German medium tank then in service. General Heinz Guderian, commander of Panzer Group II and Germany's foremost armoured warfare theorist, encountered T-34 seconds during the drive toward Moscow in July and August 1941. His memoirs, published after the war, described the shock of discovery. Numerous Russian T-34 tanks went into action and inflicted heavy losses on the German tanks. The superiority of the Russian 76.2mm gun and the thick armour of the T-34 became evident. The Germans were compelled to use 88mm anti-aircraft guns in the anti-tank role. This admission from Germany's most celebrated Panzer commander carried significant weight. The vaunted German Panzer divisions that had crushed France in 6 weeks and conquered Yugoslavia in 11 days now faced enemy tanks technically superior to their own equipment. The psychological impact on German tank crews proved severe and immediate. German medium tanks in 1941 consisted primarily of Panzer III and Panzer IV variants. The Panzer III mounted either a 37mm or 50mm main gun, with frontal armour between 30 and 57mm, thick depending on model. Combat weight ranged from 19 to 23 tons. The Panzer IV mounted a short-barreled 75mm gun, designed primarily for infantry support rather than anti-tank combat, with frontal armour 50mm thick and combat weight of approximately 25 tons. Both German tanks employed conventional vertical armour arrangements and gasoline engines producing approximately 300 horsepower. Neither German tank could reliably penetrate T-34 frontal armour from combat ranges. Neither possessed armour sufficient to stop T-34 76mm armour-piercing rounds at any range. Neither could match T-34 cross-country mobility over Russian terrain, particularly mud and snow that would dominate operations for much of each year. The T-34 represented revolutionary design thinking in every major characteristic. Its sloped armour configuration, with hull plates angled at 60 degrees from vertical, provided protection equivalent to much thicker vertical armour through. Simple geometric advantage. Armour-piercing rounds, striking angled surfaces, tended to deflect rather than penetrate, dramatically increasing effective protection without adding weight. The wide tracks, each 500mm wide compared to 400mm tracks on German medium tanks, distributed the T-34's 26-ton weight over greater surface area. This reduced ground pressure from approximately 1 kg per square centimetre on German tanks to 0.64 kg per square centimetre on the T-34. The practical effect was dramatic. T-34 seconds could cross muddy ground and deep snow that immobilized German panzers. The 76.2mm F-34 main gun fired armour-piercing rounds with muzzle velocity of 662 meters per second, sufficient to penetrate any German tank's armour from normal combat ranges. The gun's high explosive rounds provided excellent anti-infantry capability. Soviet doctrine emphasized combined arms operations, where tanks supported infantry and vice versa, making dual-purpose capability essential. But the characteristic that most fundamentally challenged German assumptions involved the T-34's power plant. Soviet designers had installed a V2 diesel engine, a 12-cylinder aluminum block design producing 500 horsepower. Diesel engines provided superior fuel economy compared to gasoline engines of equivalent power output. They also offered safety advantages. Diesel fuel was less volatile than gasoline, reducing fire risk when the tank was hit. Soviet tankers valued this characteristic highly after experiencing catastrophic fires in earlier gasoline-powered tanks. The V2 diesel gave the T-34 a theoretical maximum range of 400 kilometers on roads with a full fuel load of approximately 460 liters. Off-road range was estimated at 300 kilometers under normal combat conditions. These figures exceeded any German medium tank by substantial margins. German tanks required frequent refueling that tied them, closely to supply lines and limited operational flexibility. German intelligence had received reports about diesel-powered Soviet tanks before Operation Barbarossa, but dismissed them as unlikely. Diesel engines required sophisticated fuel injection systems and precision manufacturing that intelligence assessments concluded Soviet industry could not produce at scale. The abandoned T-34 near Smolensk proved those assessments wrong. Soviet industry was mass-producing diesel tank engines of remarkable capability and efficiency. The recovery operation demonstrated another T-34 characteristic that impressed German soldiers. The tank's wide tracks and low ground pressure allowed it to cross terrain that German recovery vehicles could not navigate without assistance. German soldiers had to construct corduroy roads of logs laid perpendicular to the route, just to bring their own recovery equipment to the abandoned tank's position. The T-34 was eventually extracted and transported by rail to the Kummersdorf proving ground south of Berlin. There, Wehrmacht testing engineers would conduct comprehensive evaluation of every T-34 system and component. The testing program would produce detailed technical reports that circulated through German armor commands and industrial ministries. What those reports revealed would fundamentally alter German tank development priorities. September 1941. Kummersdorf Proving Ground, Brandenburg, Germany. The captured T-34 rolled off the transport rail car bearing hasty German markings identifying it as Panzer 34, captured Tank 34. Kummersdorf engineers had been analyzing intelligence reports about T-34 characteristics for weeks while awaiting the vehicle's arrival. Physical examination would reveal whether battlefield reports had exaggerated Soviet capabilities or if the Red Army genuinely possessed technically superior armor. Initial inspection confirmed many battlefield observations and revealed additional surprises. The T-34's construction quality appalled German engineers accustomed to precision manufacturing. Welds were rough and uneven. Surface finishing was crude with tool marks visible throughout the interior. The cast turret showed porosity and surface irregularities that would fail German quality control inspection immediately. The driver's compartment lacked basic ergonomic considerations that German designers deemed essential. Instrument placement seemed random. Control linkages were brutally direct with minimal mechanical advantage, requiring significant physical strength to operate. The driver's hatch opened to the right side, partially blocking the driver's vision when open, a design choice no German engineer would accept. The transmission offered only 4 forward speeds compared to 5 or 6 speeds common in German tanks. Gear synchronization was non-existent, requiring skilled double clutching for smooth operation. The steering mechanism used clutch and brake controls that demanded constant driver attention and significant physical effort, particularly during extended operations. Every detail suggested primitive manufacturing by workers with minimal training, using unsophisticated tools and equipment. German engineers documented these deficiencies thoroughly in their initial reports, noting that Soviet manufacturing quality was substantially inferior to German standards. This assessment would prove accurate regarding manufacturing sophistication while simultaneously missing the fundamental point about practical battlefield effectiveness. The testing program began with automotive trials designed to evaluate the T-34's mobility characteristics and powertrain performance. German test drivers, all experienced tankers, drove the T-34 through obstacle courses while engineers recorded data on fuel consumption, engine temperatures, transmission behavior, and overall handling characteristics. The results challenged German assumptions about the necessary relationship between manufacturing quality and operational performance. Despite crude construction and primitive controls, the T-34 performed remarkably well across most evaluation criteria. The diesel engine provided smooth power delivery across its entire operating range. Starting procedures were straightforward even in cold conditions, contrary to German beliefs that diesel engines could not function in Russian winter temperatures. The wide tracks provided exceptional cross-country mobility. The T-34 crossed obstacles and traversed terrain that German test drivers judged impassable for Panzer III or Panzer IV vehicles. The sloped armor demonstrated deflection characteristics that exceeded theoretical calculations, with test rounds glancing off surfaces that would have penetrated comparable thickness of vertical armor. But the characteristic that most concerned German engineers involved fuel consumption and operational range. Systematic testing confirmed that the T-34 achieved extraordinary fuel efficiency for its weight and performance class. On paved roads at steady cruising speed, the T-34 consumed approximately 100 litres per 100 kilometres, equivalent to roughly 1 litre per kilometre. With 460 litres of internal fuel capacity, this provided maximum road range exceeding 450 kilometres, approximately 280 miles. Cross-country testing produced fuel consumption of approximately 130 to 150 litres per 100 kilometres, depending on terrain difficulty. This reduced operational range to 300 to 350 kilometres off-road, approximately 190 to 220 miles under realistic field conditions. Even accounting for combat operations with frequent speed changes, extended idling, and tactical maneuvering, the T-34 maintained operational range exceeding 200 kilometers, approximately 125 miles, before requiring refueling. These figures shocked German engineers familiar with Panzer III and Panzer IV fuel consumption characteristics. German medium tanks achieved road ranges of approximately 150 to 165 kilometers with internal fuel only. Combat operations reduced effective range to perhaps 100 kilometers before fuel exhaustion forced cessation of operations. The T-34 could operate twice as far as German tanks on internal fuel alone. The strategic implications were immediately obvious to anyone who understood mechanized warfare's logistical requirements. Tanks that could operate 300 kilometers on internal fuel could exploit tactical breakthroughs by advancing deep into enemy rear areas, severing supply lines, and creating operational chaos before defenders could respond. Tanks limited to 100-kilometer combat radius remained tied to supply lines and could not effectively exploit opportunities requiring rapid deep penetration. The V2 diesel engine particularly impressed German engineers despite their documented concerns about its manufacturing quality. The engine produced 500 horsepower from approximately 38.8 litres of displacement, achieving power density comparable to German gasoline engines while consuming significantly less fuel per horsepower hour. The aluminum construction reduced engine weight substantially compared to German cast-iron engines, improving the T-34's power-to-weight ratio to approximately 19 horsepower per ton. German Panzer III and Panzer IV achieved approximately 13 to 15 horsepower per ton, depending on variant. This power advantage gave the T-34 superior acceleration and sustained speed cross-country. Combined with low ground pressure from wide tracks, the T-34 could maintain tactical mobility that German tanks simply could not match across Russian terrain. German testing reports documented additional V2 engine characteristics that challenged assumptions about diesel technology. The engine started reliably in temperatures down to -20 degrees Celsius using compressed air starting systems. German intelligence had believed diesel engines would prove inoperable in Russian winter conditions that regularly reached -30 degrees Celsius or colder. The V2 demonstrated that properly designed diesel engines could function effectively in extreme cold with appropriate starting systems. The engine's torque characteristics provided excellent low-speed pulling power, allowing the T-34 to traverse obstacles and climb grades that defeated German tanks with less torque. The diesel fuel's lower volatility reduced fire risk substantially compared to gasoline engines. German crews had experienced catastrophic fires when gasoline engines were penetrated by armor-piercing rounds. The T-34's diesel engine, while not invulnerable, was significantly less likely to burn when hit. Kummersdorf engineers compiled comprehensive technical reports throughout September and October 1941. These documents, classified and distributed only to senior Wehrmacht officers and armaments ministry officials, painted a disturbing picture of Soviet technical capabilities that contradicted pre-war. Intelligence assessments. Soviet industry, despite crude manufacturing methods and apparent disregard for precision quality control, had produced a medium tank superior to German equivalents in most tactically significant characteristics. The T-34's fuel efficiency and operational range received particular emphasis in German internal assessments. Colonel General Franz Halder, Chief of the German Army General Staff, recorded in his diary on September 23, 1941, that examination of captured T-34 tanks revealed Soviet diesel engines with remarkable fuel economy, providing operational ranges far exceeding German vehicles. He noted that this characteristic posed significant operational problems for German forces attempting to encircle and destroy Soviet armored formations. T-34 seconds could simply drive out of encirclements before German forces could close the trap, escaping at ranges German tanks could not match without refueling. The testing program at Kummersdorf expanded through late 1941 as additional captured T-34 seconds arrived from the Eastern Front. Each vehicle underwent systematic evaluation, with engineers documenting any variations between examples. Soviet production had been distributed across multiple factories, including the Kharkov locomotive factory, Stalingrad tractor factory, and facilities in the Urals that were expanding rapidly as Soviet industry evacuated eastward away from German advances. Engineers noted manufacturing variations between T-34 seconds from different factories, but all shared the fundamental characteristics that made the design formidable. All featured sloped armor configurations, wide tracks, diesel engines, and the long-barreled 76mm main gun. Soviet standardization ensured that key components remained interchangeable, regardless of which factory produced them, a characteristic German industry struggled to achieve with its own tank production across multiple manufacturers. By November 1941, German armor commanders on the Eastern Front were filing reports documenting how T-34 fuel efficiency translated into tactical advantages on the battlefield. The 6th Panzer Division combat log from October 1941 described an engagement where German forces identified a group of approximately 15 T-34 seconds advancing toward German positions. German tanks moved to intercept and engage the Soviet formation. The T-34 seconds, instead of accepting battle, simply accelerated and drove past German positions at high speed, using their superior cross-country mobility to avoid engagement on German terms. German Panzer IIs attempted pursuit, but could not match T-34 speed across broken terrain. After pursuing for approximately 50 kilometers, German tanks were forced to break off the chase due to low fuel levels, while the T-34 seconds continued eastward, apparently still possessing adequate fuel for extended operations. The frustration in the division commander's report was evident. German tactical doctrine emphasized encirclement and destruction of enemy forces through rapid mobile operations. But if enemy tanks could simply outrun German panzers by virtue of superior fuel economy and operational range, encirclement became impossible without overwhelming numerical superiority that could physically block all escape routes simultaneously. Winter operations in late 1941 and early 1942 demonstrated additional T-34 advantages. The diesel engines, once warmed, continued operating in temperatures that immobilized German gasoline engines. German tanks required extensive cold weather starting procedures, including heating engine coolant with external fires. Even with these procedures, many German tanks simply would not start when temperatures dropped below -30 degrees Celsius. Soviet T-34 seconds, equipped with compressed air starting systems and diesel fuel that did not congeal as readily as gasoline at extreme low temperatures, maintained higher operational readiness rates during winter months. German maintenance reports documented that typical Panzer battalions achieved perhaps 30 to 40% operational readiness during winter, with most vehicles down due to cold weather-related failures. Soviet tank brigades maintained substantially higher readiness, with 60 to 70% of T-34 seconds operational, even in extreme cold. The disparity in fuel consumption became even more critical during winter operations. German supply lines, already strained by vast distances and partisan attacks, struggled to deliver adequate fuel supplies to forward units. Deep snow made cross-country movement impossible for wheeled supply trucks, forcing supplies onto railroads that Soviet forces had thoroughly destroyed during their retreats. German engineers worked frantically to convert Soviet rail lines from Russian broad gauge to standard European gauge, but the work proceeded slowly and never kept pace with advancing front lines. Under these conditions, fuel shortages affected German armoured units constantly. Unit war diaries from the winter of 1941 to 1942 document recurring entries describing operations cancelled or restricted due to insufficient fuel. Tanks sat immobilized not from enemy action, but from empty fuel tanks with no resupply available. Soviet forces, operating closer to their own supply bases, and with tanks that travelled twice as far on equivalent fuel quantities, maintained operational flexibility that German units could not match. The T-34s' fuel efficiency transformed from a technical specification into a decisive operational advantage as winter deepened. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The crisis in German tank development became undeniable by late November 1941. Field commanders were demanding tanks that could match T-34 capabilities. German industry struggled to respond within technical and production constraints that limited available options. Simply upgrading existing Panzer III and Panzer IV designs could not produce vehicles matching T-34 operational range without fundamental redesign, including adoption of diesel engines. A special commission convened on November 25, 1941, to address the T-34 crisis. The commission included representatives from the Army Weapons Office, German armour manufacturers including Daimler-Benz, MAN, Henschel, and senior Wehrmacht officers with Eastern Front combat experience. The meeting's purpose was explicit: determine how German industry should respond to T-34 technical superiority, particularly regarding operational mobility and fuel efficiency. The commission examined several proposals. Daimler-Benz proposed a design closely copying T-34 characteristics, including diesel engine, sloped armour, and similar overall configuration. This design, designated VK3002DB, would have featured a diesel engine and many T-34-inspired elements. However, the proposal faced immediate objections from Wehrmacht officers concerned about manufacturing complexity and the time required to develop diesel engine production capacity. MAN proposed an alternative design, the VK3002 MAN, that incorporated sloped armour and improved firepower, but retained gasoline engine technology familiar to German industry. This design would become the Panther tank. The compromise preserved German manufacturing advantages while adopting some T-34 lessons regarding armour configuration and main gun performance. Critically, the Commission decided against developing diesel engines for German tank production. The decision reflected multiple factors, including the petroleum industry's existing investment in gasoline production capacity, concerns about disrupting established supply chains, and doubts about German industry's ability to mass-produce diesel engines with required reliability, given the sophisticated fuel injection systems diesel technology demanded. This decision would prove consequential. By retaining gasoline engine technology, German tank designers accepted continued fuel efficiency disadvantages compared to diesel-powered Soviet tanks. The Panther tank that emerged from this process would mount the powerful 700-horsepower Maybach HL 230 gasoline engine, providing excellent performance but consuming fuel at rates that perpetuated German operational range. Problems. The Panther's operational range on roads was specified as approximately 200 kilometers, with 730 litres of internal fuel, marginally better than Panzer IV, but still substantially inferior to T-34 capability. Under combat conditions, Panther operational range fell to perhaps 80 to 100 kilometers, barely exceeding earlier German tank generations and remaining far short of T-34 performance. German tankers on the Eastern Front learned to work within their vehicles' fuel consumption. Limitations through tactical adaptation. Standard procedures emphasized defensive operations from prepared positions rather than mobile warfare requiring extended movements. Tank battalions positioned themselves carefully to minimize fuel consumption, moving between defensive positions. Offensive operations received strict fuel allocation, limiting how far units could advance before requiring resupply. These limitations degraded German operational flexibility substantially compared to the mobile warfare doctrine that had brought spectacular successes in the war's early campaigns. The ability to conduct deep penetrations and rapid encirclements depended fundamentally on armoured units, maintaining mobility across distances that German logistics increasingly could not support. Captured German documents from 1942 and 1943 demonstrate how fuel consumption concerns dominated operational planning. The 24th Panzer Division War Diary from August 1942 noted that a planned attack towards Stalingrad had to be cancelled when fuel deliveries failed to reach forward units. The division's tanks sat immobilized for 3 days, awaiting fuel trucks that arrived only after Soviet forces had reinforced the sector, eliminating the tactical opportunity. The 11th Panzer Division reported in September 1942 that its effective operational radius remained limited to approximately 40 kilometers from supply points due to fuel consumption, requiring reserve fuel for return movements. This restriction meant the division could not effectively pursue retreating Soviet forces or exploit breakthroughs beyond that 40-kilometer range without establishing forward refueling points, a time-consuming process that often allowed Soviet forces to escape encirclement. Meanwhile, Soviet T-34 brigades demonstrated the operational flexibility that superior fuel economy provided. Soviet operational reports from the defense of Stalingrad in late 1942 described T-34 units conducting raids up to 150 kilometers behind German lines, attacking supply convoys and rail facilities before withdrawing successfully to Soviet lines. German armor could not effectively pursue these raids because German tanks lacked the operational range to chase T-34 seconds across such distances and return to base without refueling, which was impossible in Soviet-controlled territory. The contrast became even more pronounced as Soviet industry dramatically expanded T-34 production throughout 1942 and 1943. Soviet factories relocated beyond the Urals produced T-34 seconds, in numbers that eventually exceeded 30,000 vehicles by war's end. This mass production benefited from the T-34's relatively simple design and diesel engine technology that proved easier to manufacture at scale than complex German gasoline engines with their multiple carburetors and sophisticated ignition systems. German intelligence compiled regular assessments of Soviet tank production based on captured documents and prisoner interrogations. These reports documented Soviet production figures that shocked German planners. The Soviets were producing T-34 seconds at rates exceeding German production of all tank types combined, while simultaneously fielding those tanks with superior operational range that multiplied their effectiveness. The mathematics were brutally straightforward. If Soviet industry produced 3 T-34 seconds for every German panzer, and each T-34 could operate twice as far on internal fuel, Soviet forces achieved roughly 6 times German operational mobility per equivalent fuel expenditure. This disparity meant German armoured forces faced not just numerical inferiority, but fundamental operational disadvantages that tactics alone could not overcome. German use of captured T-34 seconds in combat operations provided direct evidence from German crews about the vehicle's fuel efficiency advantages. Multiple German panzer units employed captured T-34 seconds to supplement their own tanks, particularly as German tank production failed to replace combat losses. These captured tanks, designated Panzer Kampfwagen T-34 747 or, in German nomenclature, served in various roles including reconnaissance, mobile reserve, and frontline combat. German crews universally praised the T-34's operational range in reports and letters. Crewmen noted they could conduct extended operations without worrying constantly about fuel exhaustion, a concern that dominated operations in German tanks. The ability to maneuver freely without fuel anxiety translated into tactical flexibility that German-built tanks simply could not match. Unteroffizier Hans Becker, a German tank commander who operated a captured T-34 with the 23rd Panzer Division in 1943, wrote in a letter preserved in German military archives, "The Russian tank drinks fuel like a moderate gentleman at a beer garden, while our Panthers gulp it like drunkards at Oktoberfest. We can drive this T-34 all day and still have fuel remaining. In a Panther, we would already be calling for the fuel trucks." The contrast was not merely colourful language, but mathematical reality. Combat reports from units operating both German and captured Soviet tanks documented the disparity in fuel consumption systematically. The 1st Panzer Division employed several captured T-34 seconds in early 1943 and maintained detailed logs of their operations compared to German-built tanks. Over a 2-month period from March to April 1943, the division's T-34 seconds averaged 280 kilometers between refueling under mixed road and cross-country conditions. The division's Panzer IVs averaged 145 kilometers between refueling under identical conditions. The division's newly arrived Panthers averaged barely 100 kilometers between refueling due to their 700 horsepower engines, consuming fuel at prodigious rates. These real-world operational figures validated Kummersdorf testing data and demonstrated that T-34 fuel efficiency provided decisive advantages in sustained operations. The implications extended beyond individual tank capabilities to fundamental questions about force structure and logistics capacity. Soviet industry achieved additional advantages through standardized diesel fuel logistics. The Red Army's diesel-powered tanks, trucks, and tractors all consumed the same fuel type, simplifying supply chains substantially. German forces required separate supply chains for gasoline-powered tanks, diesel-powered trucks, and aviation gasoline for aircraft. This multiplied logistics complexity and strain on already inadequate supply infrastructure. The impact became catastrophically evident during major German offensives that required sustained mobile operations. Operation Citadel, the German offensive at Kursk in July 1943, demonstrated fuel consumption problems at operational scale. German forces assembled over 2,700 tanks and assault guns for the offensive, the largest concentration of German armour ever achieved on the Eastern Front. The offensive plan required German armour to penetrate deep into Soviet defensive positions, then exploit the breakthrough by advancing rapidly to encircle large Soviet formations. The plan assumed fuel supplies could sustain continuous operations for approximately 2 weeks of intensive combat. Neither assumption proved valid. German armour penetrated Soviet positions but consumed fuel at rates exceeding supply capabilities. Panthers, rushed into combat before reliability problems were resolved, experienced mechanical failures and massive fuel consumption that immobilized significant numbers within days. Even when fuel supplies arrived, distribution to forward units proved impossible across terrain devastated by combat and Soviet demolitions. The 6th Panzer Division reported on July 12, 1943, that 60% of its tanks were immobilized due to empty fuel tanks, despite fuel supply trucks being located less than 20 kilometers behind the front lines. Soviet air attacks and artillery fire made forward fuel movement impossible during daylight. Night resupply partially relieved the shortages, but by then Soviet counterattacks had eliminated the tactical opportunities the fuel-starved tanks could have exploited. Meanwhile, Soviet T-34 brigades conducted mobile counterattacks that German armour could not effectively pursue due to fuel constraints. Soviet commanders deliberately avoided decisive tank-on-tank battles, instead using their mobility advantages to attack German supply lines and artillery positions, forcing German armour to react and burn scarce fuel reserves. The strategy exploited German fuel consumption vulnerabilities ruthlessly and effectively. By late 1943, the pattern had become unmistakable across all Eastern Front operations. German armour possessed individual vehicles with impressive specifications, including thick armour and powerful guns. But those vehicles could not sustain mobile operations across distances that modern warfare required. Soviet armor, built around the T-34 with its exceptional operational range, could operate freely across vast distances, concentrating against German weak points, then withdrawing before German armor could mass for counterattack. The strategic mobility that fuel efficiency provided proved more valuable than tactical superiority in individual engagements. German commanders understood this reality increasingly as the war continued. Field Marshal Erich von Manstein, commanding Army Group South, wrote in a 1944 assessment that Soviet armor's ability to operate far from supply bases fundamentally changed operational possibilities on the Eastern Front, forcing German forces into reactive strategies that surrendered initiative to the enemy. German industry attempted to address fuel consumption problems through various expedients, including auxiliary fuel tanks that could extend operational range. The Panther received provisions for external fuel drums that could be jettisoned before combat. These provided approximately 200 additional litres of fuel, extending theoretical range by perhaps 50 to 80 kilometres under ideal conditions. However, external fuel tanks created their own problems. They were vulnerable to enemy fire, potentially igniting when hit. They required time to mount and secure. They couldn't be refilled in the field without specialized equipment. Most critically, they required fuel to fill them, which German logistics already struggled to provide for internal tanks. Auxiliary fuel capacity meant nothing when supply chains could barely deliver fuel for standard tank loads. The fuel crisis intensified throughout 1944 as Soviet offensives pushed German forces westward across Ukraine and Belarus. German supply lines lengthened dramatically, while Soviet logistics improved by operating closer to intact rail networks and supply bases. The disparity in operational mobility widened further as German fuel stocks dwindled and allocation priorities shifted increasingly toward defensive operations. The liberation of Eastern Europe in summer 1944 produced overwhelming physical evidence of German fuel problems. Soviet forces advancing across Ukraine and Poland found hundreds of abandoned German tanks and assault guns along retreat routes. Remarkably, many showed no significant battle damage. All had empty fuel tanks. German crews had attempted to destroy vehicles they could no longer move, but often lacked even the fuel necessary for demolitions. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.